Okay, so in the last portion, we're going to talk about, first we're going to talk about the Simpsons rule. The Simpsons rule is really, it is a, if I have, I'm going from A to B, and I have and such like this. Okay, what Simpson rule says is this, is if I have a parabola, which I have like this, if I have a thing like this, and I go like this, so each three of these, so if I have one strip or two strips here, the area under this curve, if this is, if I'm going to call this y naught, this would be y1, this would be y2, the area under this curve right here, from here to here, so these two strips, the area underneath is going to be equal to 1/3, if this is, well, each of these is h, so it'll be h over 3, and then it's going to be y0 plus 4y1 plus y2. Okay, so you take this guy and add it to the edge, to add the two edges, multiply the one in the middle by 4, and then you divide that by 3, and you got the area underneath this part of the parabola. Okay? So this requires you to, so you're going to have two strips at a time. You're going to have two strips at a time. Okay? So the next one is going to be what? It's going to be y2 plus 4y3 plus y4. Okay, the next one is going to be what? The next one is going to be y4, the one you ended with over here, plus 4y5 plus y6. Okay, so now essentially what it does is it requires you to be like this. So you have to have even number of strips here. If you add these together, what do you get? If you're going to do the same thing that we did last time, we're going to get h over 3, and we're going to get what? 1y0 plus 4y1s. Then we're going to have 2y2s plus 4y3s. Then we're going to have 2y4s. So it alternates, right? 4, 2, 4, 2, all the way till we get to the 4, whatever it is. And then we're going to end with whatever 4y minus n1 to the 1, and then 4y to the n. Okay? So you're going to get, instead of the trapezoid rule, we had h over 2, and then we had y0, 2y, 2y2 plus 2y3, 2y4, where we kept it going until the very end, where we only had 1. Here we're going to go in a sequence that goes y0, 4, 2, 4, 2, 4, 2, 4, 2, and on, right? Until the very end, we're going to have 4, and then we're going to have the very end of yn, okay? And that's how you do the Simpson rule. So if you go page, on the bottom of page 317, it says the Simpsons rule. To approximate a to b, f of x dx, we're going to say s instead of t, right? Because it's Simpsons rule, right? Y over 3, y naught plus 4y1, 2y2, 4y3, on and on and on until we get 4y sub minus n minus 1 plus y to the n. Okay? So where a to b is partitioned into an even number of n subintervals. I'm going to explain to you why you had to have even numbers, right? Because they have to be worked in pairs like this. Okay. Just a interesting note here. Simpson had nothing to do with developing this rule. Okay. He did not find this out. He did not do the calculations. All he did is he mentioned it. Okay. Simpson rule actually goes back to Johannes Kepler, who is widely known as the father of modern astronomy, who set out the 3 basic laws of astronomy, okay? So Kepler is the one who first brings it up, but even so, Kepler was not the one who actually developed it. It was a long used formula from the people who used to make wine. The winemakers had a way to calculate the area underneath a curve because they needed to find out how large or how much wine the keg would actually hold. Okay. And so actually that's where this all originates from. It's kind of like Pythagorean theorem, right? Pythagorean theorem is attributed to Pythagoras, but Pythagoras is actually not the one who develops it. He's the one who widely spreads it out and lets it know that it's available. Okay, there's actually proof that the Babylonians had that rule 1,000 years before Pythagoras was even born. Okay, so, you know, same thing here, okay? It's called the Simpson's rule because Simpson used it in one of his proofs. And that's the only reason why it's called Simpson's rule, okay? Okay, so yeah, I guess we'll do example number 3. Let's do example number 3 and see if we can actually use this rule. Example number 3. Okay, we are trying to find from 0 to 2, 0 to 2, 5x to the 4th dx. Okay, all right, and blah, blah, blah. N equals 4, we're going to use n equals 4. So we're going to have two, 1.5, 1.5. So y0 is going to be this guy here. So y0 is going to be equal to 0. y1 is going to be equal to 0.5 to the 4. Let's write this. 5.5x to the 4th. y2 is going to be equal to 5, 1, x to the 4th. y3 is going to be equal to 5 times 1.5, x to the 4th. y4 is going to be equal to 5, 2, x to the 4th. 2 to the 4th. Okay, so the Simpson rule says it's going to be equal to h, which is one sliver here. H is going to be what? H is 0.5, so it's going to be 0.5 divided by 3. We start with this guy, 0 plus 4 times this. Okay, times that, plus 2 times that. 4 times that. Plus, the last one's only going to use once, right? So that's what it would look like, right? Okay, so that's what it looked like. That's how you do it. You can just plug it into your calculator and it's going to come up with something. And it's going to be 385 over 112. Okay? If you were to do this algebraically, what would you get? How would you do this? Lauren, how do you do this algebraically?
Wouldn't you just take your integral,
What's
your
the
2 and 0?
So what's the antiderivative of this?
That would be x to the 5th.
X to the 5th. And you would go from 0 to
2.
Right? So if you do that, you're going to get 2 to the 5th minus 0 to the 5th, 32. Right? So what do I get here? If I do this, I'm going to get, this is the same as 365, no, 45. So 45, so it'll be about 433, 369.75. Okay, 33.75 versus 32. Okay, again, even when I only do 4 strips, I'm pretty close here. Okay, all right. All right, last but not least, there's what we call the error analysis. Go to page 319. It says if the trapezoid rule and the Simpson represent the approximations to the integral of a to b f of x dx, we're on page 219 here, given by the trapezoid and Simpson rule, respectively, then the errors for each of them satisfy that. Okay. B minus a over 12, h squared, where h would be what? H is each increment's strip length. And then you have that m thing there. Okay. That m thing is something new. Okay, what is the m thing there? M is, if you go to page 318, it shows you what that m is, right? Where is that? It's the maximum value of the fourth and the fourth derivative. That's something with the fourth derivative, maximum value, or something like that, okay? So I'm not gonna go ahead and have you guys do this, okay? You're gonna have to do the homework, okay? So you can get a little bit of appreciation of what's going on here, okay? This gives you the error bound, So the error for the trapezoid rule is bound by, or the maximum error is b minus a over 12, h squared times m f to the second, that's the f to second derivative, all right? And similarly, the Simpson error is also bound. But just know that there's a bound there, okay? But I will have you do the homework. I think I actually assigned a couple of homeworks there too about that. Maybe I did, maybe I didn't, I don't know. But anyway, okay, just know that there is an error bound there. You're bound by the maximum error can only be so large. Okay. All right, we're done. We are done with 6.5, and we are done with now chapter 6.